identify these t-shirts that we have. And I think to identify these t-shirts, we'll assign them a Roman numeral in the order of the people that are on this list. So I'm first. It'll be the first shirt I wear will be Roman numeral 1, and as that shirt gets worn by other people, it will still be Roman numeral 1, and we'll attach a note to that so that each person that wears that shirt can initial it, so we'll know the sequence in which it is worn. Now, will that tell us? Yeah, that should tell us what shirts everybody had on in the interim. Am I right? Let's see. If you, because, yeah, that's what I'm saying. On the, yeah, you could actually just initial the shirt itself in a row so that we don't have to lose a piece of paper. Okay. No. So I think that'll work. Why don't we do this? Why don't everybody now take the opportunity of putting on whatever shirt they have, and I'll hand out these sweatshirts, and if you just mark your initial, your, first of all, the sweatshirt, the t-shirt number on the t-shirt, and the first person's initial on the shirt, and why don't we write them all right in the upper right-hand corner of the shirt, just, you know, first name, second name, third name, right down the front. Doesn't make any difference. And let's put them on inside out, and take them off that way, because I'm always in the habit of processing the outside of garments, and so we just do it that way to be consistent. Okay, everybody clear where we're going? Okay, so let's just do that. That's all right. Oh. Well, I have, you know, powdered glass on my shirt. If that's a concern, I didn't even think of that. I mean, there's probably a picogram of glass on my shirt. I didn't put much. If you think it's a problem, then what I would suggest is either if you feel better about shaking it off and getting rid of the big chunks, or not using it, that's fine too. Whichever. Or maybe Bob said he'd wear it. Good. Good. Yeah. Right. So I don't know how to address your problem. If you don't want to wear it, then I would just say not wear it, and just put on one of these shirts over the shirt you have on, and then we'll just see what happens. Because you know, at the very least, we'll get some secondary transfers in that process, which would be interesting to see anyway. So, yeah, it's not really anything lost. Yeah. Or I'll get you a dummy out of the lab. We'll put it on the dummy. Ed, no. Okay, I'm gonna awful lot of information in a 5-digit number. Also allows you to computerize lists of trace evidence. If you have 400 or 500 things you've looked at in a case, and you want to know where's the red polyester fiber, trying to look through pages of notes is a little bit inefficient. On a computer, you can sort it, do a lot of stuff, and I've actually made identifications I wouldn't have made, or made comparisons I wouldn't have made by computer sorting it. So that's his first thing. I'm going to just let everybody take one. This second package it has basically 3 documents. The last document is how to fold a bindle. This is my apologies to Travis Owen in New Orleans, who first got so frustrated with cops folding things up in old torn newspapers and dirty socks and stuff that he had this done. So I sort of copied it from him. The other two documents in this list I'm passing out just for people's interest. There are two documents that have been adopted by the ASTM Committee E30 in Forensic Science having to do with documentation and labeling of evidence items and how to keep track and keep records and how to identify so that items can be uniquely identified. We'll talk a little bit about that, how to do that in a minute. So everybody can take one of those. Anybody doesn't get one of those things, let me know and I'll make another copy and send it out. I don't know if it looks like there's one extra too. So let's talk a little bit about the process of documenting evidence. And basically when I say that, I mean I expect when a piece of evidence becomes significant in a case and a fiber comparison is made or a hair comparison is made, that every stage in the processing of that particular item, that hair or fiber, is documented. When it was done, who did it, what was done to it, and so there can be no doubt that we're looking at the right thing. And I'll show you how I do that, and other people have alternate ways of doing it. When I get evidence in, whatever it is, I give it a number that I assign to it. I don't use agency numbers because agencies have such crazy ways of assigning numbers that I can never be sure that the numbers they use are unique. You'll notice that the standard calls for identifying things with a unique number, so we don't want any 4 number 5s in the same case. It has to be traceable, and I like them to be sequential because when I return evidence, I like to go through that evidence and say, I got item 1 through 100, and here's item 1 through 100. There's 100 things. I'm returning everything. If you have non-sequential numbers, you never know. Somebody says, I gave you item BG46, and there's no BG45 or 47. You have no idea whether you got that, whether you're returning it. To me, it makes a bookkeeping headache. So this is the way I do it. We have a case number and an item number, which are numerical. So this signifies the item I got in, whether it's a shirt or a microscope slide with a hair on it. It won't be a bag of clothes. If it's a bag of clothes, I'll go through it and itemize each shirt, pair of pants, or whatever. Even if they're not separated in the bag, I'll keep track of the fact that they're not separated, but I would give each one a separate item number. As I go through the process of isolating things from this, they just get sequential numbers separated with a dash. So I might take a series of tape lifts that would be numbered 5-1, 5-2, 5-3, and 5-4 from 4 areas of the garment. As I examine this tape lift, I might find some fibers or hairs I remove. Normally when you're examining a tape lift, you're removing one thing at a time, and so that's one thing that gets a unique item number. Sometimes if you have situations where you do subdivisions, where you have, let's say you have some loose debris you pick off and then you pick all the hair out of it, that might be item 5, might be all the hair off this shirt. Then you might have item 5-1 is all the long blonde ones you want to look at, and item 5-1-1-1 is some particular hair that's of concern. So these numbers can get, sometimes they get out to the 5th number, but pretty rarely. Usually the 3rd one is as far as it'll ever get. Now the only exception to this is in the situation where you have what I would refer to as a subsample. Let's say you have a shirt and you want to prepare a microscope slide with standard fibers from that shirt. I would just call that then 5A. And I know when I look at that number that that's really not that particular microscope slide isn't really a significant item in the case. I could just throw that away because I got a whole other shirt to get more stuff from if I wanted to. So anytime I have that kind of a sub-sample that's of not any real significance, mainly just for handling purposes, I would give it a letter designation like that. This number would be marked actually on the evidence or on the label of the evidence and go along with the evidence. I used the wrong pen. I'm a big critic of a microscope slide that's labeled Q hair. I mean, where was that from? When was it taken from the evidence? Who took it is of minor importance, because presumably the person who wrote that will know that he or she took it, but there's no way of establishing when it was taken, and that's critical because you want to know when you're looking at the evidence that there's no possibility that you accidentally looked at something else first. It gives you a good feeling when you isolate a piece of evidence that turns out to be critical in a case, and you can go back through your notes and realize that you didn't even have in the laboratory the comparison material for that piece of evidence until after you had isolated this in a permanent mount on a microscope slide. You know that you didn't contaminate it in the laboratory. Now, if you don't have a date on there, you might think you did, but you never be able to prove it to anybody. So, but this number, you should then be able to go back in your notes, find where this item was isolated, should be listed in your notes, and that page in your notes should be dated and in sequence, and then you can answer that kind of question. I also don't label slides on the slide itself because those labels wear off real easily, is one reason, but probably the most important reason I do that is because since I get lots of slides prepared by other people, I use white labels and I always know the slides I prepare because I'm the only one I've ever seen that does that, so I know my slides from slides that are submitted. It's just easy to look at them quickly and know which ones I did and which ones somebody else did. I'd be interested in any comments anybody has on all this. If you have some comment, please speak up, because I know there's not universal following of this practice, and maybe not even universal agreement with its desirability. And if somebody has a comment, feel free to interrupt me. I guess not. Yeah, or a lot of times you'll see a piece of tape put over the end. There's a lot of things to do it, but a Sharpie or one of those penal pen markers on a non-frosted slide comes off with the oils of your fingers real quick, and then especially if you have a slide where you're starting to put solvents on it and stuff, it washes off just immediately. And we get a lot of slides in, a lot of hair slides in that we demount for doing DNA, and it's pretty frustrating to look down the bottom of a petri dish with 10 hairs and 10 slides and no labels. But we try to anticipate that. Okay, let's talk a little bit about one of my favorite subjects is bindles, one of my favorite pet peeves. In my view, all you ever need for a bindle is this. You fold it up as instructed on the form, and you obviously after the first time you don't really need a pre-printed form. You fold it like this, fold it in thirds, like this, and then you have the space for your sample, and you can fold it down and put it in a coin envelope like this, and you have the sample. I don't like bindles like this. Mainly they're just too damn small. I mean, my fingers are too big to deal with one of these things, and if you flick the paper, the sample only has to go an inch and it's lost. Here at least you got 4 or 5 inches of margin for error. The advantage of these papers is they are slicker, and maybe somebody would do a study to show that you can get tiny quantities of blood off here better than you can a piece of bond paper, but I'm not convinced that that's the case. But you know, you do get these fancy pharmaceutical folds in that I don't even know if I know how to do, but it's something like this with the flap tucked in and all that. They're nice, but I really don't think they're necessary. And to me, they're just a lot of hassle. With this kind of a bindle, you can open it up like this, put it right under the stereo, all your samples down the groove. I usually put a pencil or something on either side to keep it flat. You can move it back and forth. You can pick stuff off. If it drops off the spatula on the way to the slide, it's going to fall right back on the paper. You can put the slide right in there. Your whole work area is right there. And most importantly, you always have it. I mean, it's just, you know, it's real easy to have. I would even say if you're going to fold it in here, like if you have a blood scraping that you want to put in a bindle, put it in a bindle like this. At least when the person opens it up, they have a workspace to open up the little bindle, and they're ready to go, rather than having to run the risk of losing the sample off one of these little bindles. So the bindle then gets marked with all the appropriate information, and then placed in one of these envelopes. Don't put tape on it. It just sticks things up. If you need to fold it closed, put a paper clip on it to hold it closed like that. I had a case I was working on yesterday, I think, where I had a bunch of big stuff in the debris from an automobile seat, a bunch of broken parts of the seat. I just picked out that broken part, put that in the bag along with the bindle that I put a paper clip on, keeps all the powdery stuff well enclosed. Yeah. Yeah. I think that's a good idea. I'm so intimidated by the variety of sizes of plastic envelopes, I've decided to solve that by never having any. So that's why I say, you know, there's no hard and fast rules to this, but I do like those little 3x5 or 3.5 by 5 plastic envelopes. Another nice evidence container, actually I haven't ever used very much of, but I've been using a little bit lately, is film cans. And I decided, we go through so much film here that I decided we ought to start using that for something. So I've been using those, and they seal nice. The only problem is they're not transparent, and the other problem is they're dark, and it's hard to see what's in them because they're just so dark. So you got to get the light right. So probably I won't continue that except for like soil samples, you know, but they are nice for soil sample or, you know, chunks of glass or something like that. But, it's not very minute particles. They pop open, right? Yeah, yeah. And they will open up if they put pressure on them from the side, and something. The lid will pop up, and they could spill it. You know, you stuff it all down the box in the oven's room. So, but there's got to be something useful to do with those things. Just bugs me. Oh, wait, write that down. What a good idea. Where we live, that's probably it. Okay, does anybody have any other questions or comments, or anybody do it substantially differently? Bob? Yeah, and you never... I'm always a little bit leery about the integrity of some of these plastic envelopes. Sometimes they don't get sealed all the way around, and I've pulled some of those out and found that it didn't, you know, the heat seal didn't work along one edge or something like that. And that's the one envelope out of 10,000 you get where you drop your sample in it, you know, hear something go click on the floor, and spend the next week looking for the thing. Any other comments? Okay, well, I guess the next thing to talk about, and I'm going to actually do this by way of demonstration, is processing a garment. A little bit of introduction. There are many ways of getting trace evidence off garments. Picking, obviously, is the preferred method because you go through the isolation immediately, and you normally even get to some stage of identification of the material when you pick it off because you recognize that it's a hair or a fiber, a chunk of glass or a piece of paint or whatever. So to the extent that you can actually pick things off, that's the way to proceed. And what do you do with the things you pick off? Put them in a bindle. You put a single fiber in a bindle, you can put a single hair in a bindle. If you have a single fiber, if it's a short one, I prefer to put it directly on a microscope slide. And I just tape down the cover slip, use the long cover slips, the 22 by 40 millimeter cover slips, put the fiber underneath it and just tape it down with a couple of pieces of tape, and it'll stay there pretty much forever. And any single particle will stay under cover slip forever. If you get more than one, of course, then it will bow over and you might lose some. But anything like that can be conveniently handled on a microscope slide. Anything else can go in a bindle. Occasionally I'll use some kind of little snap cap vial or something like that, but I'd say 99% of the time if it won't go in a bindle, it will go on a microscope slide. And that's all you need to do. So that would be the first stage of isolating the trace evidence. Now, one of the things you might do at that point is to use one of these alternate light sources. And I was thinking about getting one and demonstrating that today, but everybody can turn on a light in the dark and do the same thing. So I didn't think it was worth the time. But that does help you see particularly fibers that are fluorescent. And stains. You'll probably see more stains than you ever wanted to see, especially if it's any kind of carpet or seat covering or anything like that. But it is useful, although I think an argument could be made about whether or not with stains you actually see any more than you do with a careful examination. But it probably saves time, if nothing else, when they do fluorescent. You can just find it a lot easier than just a careful visual search. But essentially, when you do use an ALS, you're still picking off the individual things you see. So it's no different than doing it in the room light. Then you get to the next stage, which probably with most garments is either going to be scraping them off or tape lifting. A lot of laboratories, particularly the FBI, uses scraping. I think that's fine in certain circumstances. If you have separate rooms to do your examinations for unrelated items, then scraping has a certain amount to recommend it. It's probably the method that is the most selective of all the methods. It just gets the big loose stuff that is useful for comparison. But since I don't have separate rooms to do that kind of stuff, and since the general idea of knocking something off 4 feet above my table and letting it hopefully fall down and not get blown away just doesn't appeal to me, I always do tape lifts if it's a garment, almost any kind of garment. The only exception might be some of these bulky knit sweaters that have big ribs on them or something. You can't really get into those. Then you have to resort to vacuuming. But with any kind of a smooth finish garment, knit sweaters, even a sweater like the mohair, anything like that, I would use a tape lift. So I'm going to just pick a shirt, this one, and show how I go about doing that. Now, I think it's also a good idea, of course, when you're doing this kind of stuff, to wear a lab coat with long sleeves, especially for guys like me with hairy arms, because I don't like to have the people in my lab waste time doing DNA typing of my arm hair. Sometimes you go through this process routinely. You do it time after time after time. You begin to wonder, why do you do it that way? Well, I had a case the other day where I got the table all cleaned off. I brushed it off, like I always do. I put down a clean piece of paper like I always do, and I was examining a garment. I got done the examination. I looked down the examination paper, and there was a shotgun pellet, except it was a stabbing case. I have no idea where the shotgun pellet came from, but I know it wasn't on the table when I started. Okay. Okay, the first thing you do is get a piece of clean paper. First thing you do is clean off the table. There's a lot of good stuff on this table already. I'm going to throw this one away because all these little tears really screw you up when you start trying to empty stuff out of this bindle. Everything catches up on the edge of it. So, obviously on the normal exam table we have this on a dispenser that you just tear off a sheet. I knew I saw him there. We get asked all the time, why can't you just go to the other laboratory and do this examination? Well, I can't even do it in my own library when it's 10 feet from my laboratory, much less somebody else's laboratory. This paper is kind of curly. It will make do. So this is the shirt I'm doing. Now the first thing I would do is write down what I'm doing. Because when I get this shirt back in the bag and set it over there, and then now what was that shirt that I just took all that stuff from? And there's 15 bags. They all look alike. Okay. So now we'll spread it out. It's nice if you get these things in like from the corner where they're all folded nice in a piece of paper and stuff. And obviously when that happens one time out of 1,000, you unfold it, try to maintain its original shape, but obviously in this, particularly in this experiment, we haven't made any attempt to do that. So you can take a look, and I'd usually look at it with a magnifying glass, illuminated magnifier. It just helps. We just take a look and see what you see. I see a hair here, so I'll just start making bindles and putting stuff in them as I go along. And I think it's important to keep track of it as you go along, because there's two reasons for that. Sequence is important in this stuff, because if you if there's ever a question about whether there's a possibility of contamination or any of those kinds of things, you know, for example, if I turn this shirt over now and pull something off the back, there's a little bit of difference between the sample I pull off the back and the sample I pull off the front, because the back has, you know, been in contact with this sheet as I've worked on it, as I've been pressing down on it with the tape lift and all that, and what's on the front hasn't gone through that process, and there may be certain situations where you would like to know that. So I would just make a note, just mark the this is number 11, 1, and I'll just make a note in my notes: hair, left sleeve, front. And I don't see anything else. There's a little tiny hair here, but I think I'll just pick that up with the tape lift. It looks like either an eyelash hair or arm hair or something like that. Because it's of doubtful significance, or not significance, it's of doubtful utility for any further purpose, and it's just easier to, you know, that's just the way I do it. You know, maybe if it was a situation where, you know, we had a female who was alleged to wear this shirt, and maybe it has mascara on or something like that, and you wanted to, you know, you had that kind of a concern, you could pick it up, but, you know, it's just a judgment you have to make. But in this case, I'm going to. Yeah, yeah. I probably would if this whole front of the shirt was covered with hair. If I turn it over and find another hair, I won't. But you know, that's again a judgment you have to make. Depends on you know, the condition of the evidence when you get it in, how it's been packaged, what the chances are that it's significant that this hair is from here rather than from here. Obviously, in the context of this exercise, probably where it came from at all on the shirt is not going to be at all significant in any interpretation of the significance of the evidence. In other cases, the shirt. Yeah, it does start to dilute location information. That's right, it does. What happens as we get to the end when the last thing you do is you empty out the bag on the exam paper and pick up everything that wasn't even on the shirt? What is, you know, what do you do? That's right, that's right. I, you know, was talking to a woman from the Arkansas State Police Lab. They have one body bag for the state of Arkansas. They wash them out between each case. Well, we just can't afford it anymore, but we're trying better. We'll be number 45 in body bags pretty soon. So, anyway, not normally, especially on a white shirt like this. I mean, you can see things on it pretty easily, and when you look at it under any kind of light, it's going to blow your eyeballs out anyway, so there's not much point. If it's a dark garment, then I might look at it under UV looking for stains. Not routine. Bob, do you have a question? Well, sometimes you're lucky. Sometimes you're lucky. You look for shadows. That's one of the things that's nice about an illuminator. It does cast shadows. You move it around, and you begin to pick some stuff up. Anyway, let's go on to the tape lift. Again, there are a variety of ways of doing tape lifts. There's a variety of tapes to use, and there's a variety of ways of retaining the tapes. Probably the two most common are some kind of transparent, single-sided tape, like Scotch tape or fingerprint tape or something like that. And the other most common is these lint remover things that you can buy to remove lint from your clothing. The kind that have sheets of peel off, it's like sort of like masking tape texture. I know a lot of people use those. I don't like those because they're not transparent, and I don't like storing the evidence with the sticky side exposed to the air because it just attracts stuff, and you have to examine it from the sticky side, and I just don't like that. The efficiency of the operation is very nice, and I wish somebody would figure out make a transparent thing like that. I think it would be very handy. But until they do, I use just clear fingerprint tape. There's been a lot of discussion about the problem with fingerprint tape is that it's very birefringent. And there are some tapes that are hardly birefringent at all. I used to have a roll somewhere. I don't know where it went. But there's some kind of special tape. It doesn't have very much tack to it, but it's hardly birefringent at all. It's very nice because you can do a lot of optical microscopy directly on particles on the tape, and it's particularly nice for picking up debris, like from like maybe when a rock hits a windshield or something like that, or where there's a little bit of powdery mineral material left, you can press that in there and pick up enough or something like that. But it only comes in 3/4 inch widths, which makes tape lifting anything a long job, and it's not very tacky. It would last about one application on a shirt like this. So generally, I don't ever use it, obviously, because I can't even find it. Okay, so then what do you put it on? I put it on 2x3 microscope slides that I thought was under this lid. I'll have to go get some. Actually, I know what I want to get besides that too. Thank you. Here's copies of that last document I handed out that some people didn't get. I'll pass them on back. People that didn't get one. Here's why don't you take one of those because it's stapled. So it's stapled. I put the tape list down on microscope slides. Why do I use microscope slides? I have microscope slides. They're compact. You can get a lot of tape lists in a small area. They're transparent. You can look through, when you use transparent tape, you can look through either side. But I think the two most important reasons are it seals the package so that you can't get anything more on the tape lift. And just as importantly, it gives you a flat surface. So you can examine the tape lift even on a compound microscope fairly easily. If you use Petri dishes, which is the other common way of holding your tape lift, the tape will curl and you just go nuts. At least I just go nuts trying to focus on the sample, and it's so flexible that when you try to manipulate a particle under anything other than a low power of your stereo, you move the tape and it goes out of focus immediately. So somebody will explain to me sometime why they prefer the other way, but so far I've never been convinced. Have I offended anybody enough so there's no comment yet? Yep, sticky side down on a single. You can do. I mean, we'll do a little bit of that maybe today, but you can do, depending on how imaginary you are when you use a compound or even a stereo at like 60 or 80x, if you have a stereo that goes up that high, you can get a lot of fiber information from a compound microscope. You can certainly tell lobe from non-lobe fibers. You can tell whether or not they're delustered. You obviously get color information. You can tell color variation information. You get a lot of information by looking at the thing under stereo. You can tell medullary characteristics of animal hairs. Sometimes you can tell scale characteristics on a compound microscope at 100x. You get a lot of information quickly that you can't get using The tape, if you put them on a petri dish, you usually can't even get the thing on your compound microscope without mucking about with the stage because the working distance isn't big enough. And usually, what people do when they use them on a petri dish, they put the tape over. I don't even have one here. They put the tape over, then they peel it back to work on it. So they sort of lay it sticky side up. Then you have the petri dish hanging on it down here, and there's all this sticky stuff. I just know that I don't like it, but I know a lot of people do it that way, so they must have a point. So that's the other thing that people do is it's hard enough getting a piece of tape flat on something that's hard when you're trying to get two real flexible surfaces to make nice even contact with one another. It's just it's like a cat fighting its way out of a bag. So anyway, that's the way I do it. Now, sometimes I use microscope slides that are stamped with a grid like this. Now, this is what the serologists use for something, and there's it's divided up into 12 grids like this, 12 squares, and you can mark these like A, B, C, 1, 2, 3, 4. Then as you go through, you can know where to look for something. You don't have to look for the whole slide. You know in section B1 there's something you're interested in. Alternatively, what I do probably more frequently is to circle the area of interest where I see something under the stereo, for example, that I want to look at more. I'll circle it, and then I'll make a photocopy of the slide, and then I can just somehow refer to the circled area in my notes to remind myself where I'm looking, just number them sequentially or something like that. Because I normally will look at a lot of things on the tape lift before I actually pick anything off. Of course, that depends on the kind of case. If you're looking for, particular target trace evidence, whether it be hairs or fibers, whatever, then you pick off what you think when you think you see something, and you've got it. But if you're just doing a survey, you don't know what's significant, you want to do everything, you need to be able to go back and find that thing. So you need some way of indexing the slide. So I use these things, and you just stamp them. The thing I don't like about them is I can never tell which side the stamp's on. It's on this side. So what I do is I get the slide out, and I clean it off with a Kim wipe or a shirt sleeve. I don't have a Kim wipe here. Okay. So spread it out. And again, usually to keep things in order, make a little drawing in my notes. And somehow indicate on here where I'm going to take the tape lifts from. And usually in a shirt like this, I'll do it in 4 tape lifts off the front and then 4 off the back. So I'll just do like this, and then I'll number it sequentially with the thing I've already picked off. Now that, frankly, one of the problems with doing all this numbering stuff is keeping track of it so you don't duplicate numbers. And that can be a problem. You get 2 number somethings and you get confused. And so you just got to figure out a way of keeping track of that. So this first hair was number 1, so this would be 2, 3, 4, and 5. So just take the tape, pull off enough of it to work. Then I just hold it between my first 2 and last 2 fingers, sticky side down, and make sure you do something with the tail end if it sticks out, because you don't want all your evidence to be on the part you throw away. So you get it straightened out, then you remember where you started. I don't think there's any need, to make any fine dividing line. I mean, this is just a judgment thing. So you just start in one corner and just work your way of the garment. And if you find out that you're running out of stick, you gotta start all over again. You know, you gotta stop and get a fresh piece of tape and maybe revise your sampling scheme a little bit. And if you see anything, you know, see a little black speck or something, go back and pick it up. But I consider this, in the strictest sense, a sampling method. In other words, we're taking a sample of what's on there. We're not assuring ourselves that we're getting everything. We're just sampling it. And probably anything that's significant, there's still going to be more of it there. You try to be thorough, but you have to realize that there's some things that are going to be left. So then when you're done, you just take